Good morning, guys. Today our topic is mesh analysis. Okay, so for the circuit analysis, there is a two types of analysis. First one is the mesh analysis. Second one is the node analysis. You can do anyway, and sometimes we have to apply both of them. The first we have to learn how to perform a mesh analysis. This is 1 ohm resistance. This is 2 ohm resistance. This is 5 ohm resistance. This is 4 ohm resistance. This is 5 volt. This is 3 ohm. This is 6 ohm. This is 20 volt. And this is 10 volt. Okay. So this is plus, this is the plus side. So find the current to the 5 ohm resistor using the mesh analysis. Okay. So what is your mesh analysis? Mesh analysis is depends on generally KVL law. We have to apply KVL law. So first step is that is the step one. First step step one, we have to we have to choose a direction for traversing. Say we are going to the in this direction, or somehow you can take no, I am taking in this direction of traversing. So you have to apply all this is in this direction of traversing. But generally we are taking a clockwise direction. Okay, and whatever maybe you take another, but what happens, we don't know which potential is higher and which potential is lower. Say you can see this is the 20 volt potential, so maybe I am traversing in this way, but actually result will come in the negative negative current, this is resistance, so using current, so negative ampere will current. So then we have to change, or we have to assume that at our uh, direction of traversing is the opposite. Okay, because we don't know which potential in this area, which potential will be higher. So that is the 10 volt, but 1 ohm is attached. So it may be something, it is 2 volt, but some loop and voltage will be divided. So we don't know what will be the higher potential. So we abruptly take a direction. So generally we are taking the clockwise direction. So first step is to take a direction. So I am taking a direction in this way. So all loop should be direction traversing in this way. Okay. Then step second, then step two. Step two is to naming the loop. Say or the maze. Maze is the elementary element, elementary uh, elementary loop, means this is a maze, this is a one, you can't divide this maze in another, but say this is a maze, this is a loop which will be divided further in this two way. This is this maze, this is mem2 and this is m3, so you can divide it, but maze is the only elementary loop, but you can see this is a total a loop. Okay, so this is the step 2. Now we are going for the step 3. So what happens for maze analysis? First, we are I want to write down some tricks, or you can say this is the formula. Identify the maze is and assign a direction to it. Okay, first identify the maze and assign the direction of it, and this is the unknown on current for the each branch we know, and we have to determine the current through the 5 ohm resistor. This is the 5 ohm resistor. Okay, first identify the mesh and assign a direction. Okay, then assign the polarity. Assign the polarity, or you may say way of traversing. So this is positive, this is negative, so traversing is in this way. Okay, and then apply kvl, apply kvl for each mesh. Okay, then you will get, say this is a 3 mesh, so you will get 3 equation. Then we will apply, either solve by your mathematical expression, either solve by your Cramer's rules. I will explain what is Cramer's rule, then you can find out. Cramer's rules is just like a matrix representation, and directly you can find out with one or two mathematical summation. So this is the, if there is a 3 numbers of equation, 4 number of equation, then we can find this by a Cramer's rules. Okay, so today our we learned how to analyze a maze, and then Cramer rules. Through Cramer's rules we can solve it. The second step, up to this second step is done, that is your this, and now whenever second step is done, then we have to assign some current. Say this is I1 current is flowing mesh 1, this is I2 current is flowing as this is the mesh 2, this is the I3 current is flowing in through this mesh. Okay, and now uh, we can find it. Yes, this is polarity, means direction is here to here, so polarity is here. So we can solve it by the one by one for the mesh. Look, this is the KVL law third step. The third step, step 3, you can find KVL law. What is KVL law? KVL law is that summation of all voltage is equal to 0, or the summation of potential is 0. Say summation of voltage plus summation of IR, this is also potential drop, that is equal to 0. This is your KVL law. So first apply for the mesh 1. You can see in this mesh 1, if we start from here, say we are assigning 10 volt, okay? And then if we assign this, look, this is your positive, this is your positive, and this is your negative. That's why current is flowing in this direction, current is flowing in this direction. So yesterday I told you uh, what are the sign direction of sign. Positive to negative means fall in voltage, it is considered as negative. So say I1 is flowing, so I1 into 1 ohm, I into R, so this is minus I1 in I1 into this R means this is 1 ohm, okay. Then we can see this is the another register where some current is flowing, but which type of current is flowing? Look, I1 is in this direction and I2 is in this direction, okay. This is I2 and this is I1. So what will be the net current? Net current will be I1 minus I2, and this is the traversing is in this direction, so positive to negative, so we have to apply -3 minus sign, then it is 3 ohm, that's why 3, and this is uh, minus I1, sorry, I1 to the uh, I1 to the I3, sorry, I1 minus I2, I1 minus this is mesh 2, that's why I2. Now for this case, 6 ohm resistor, I1 is flowing in this direction and I3 is flowing in this direction. So what will be the net current? Net current will be I1 minus I3, and the traverse is in this direction. So this is positive to negative, because as this is positive, this is negative, that's why current is flowing. We are considering this current, this is flowing, maybe or may not be, whatever may be real, we don't know, but we have to adapt it. So -6 as per the direction, positive to negative. Then this is the 6 for the 6 ohm resistor, and this is the net current is I1 minus I3. We don't know either I1 is greater than I3 or I3 is greater than I1, because here 20 volt is there, here 10 volt is there. So, but we don't go for the, we couldn't decide it now. But as we are going through the base one, we are always assuming that our current I1 is flowing in this direction, one single direction. Okay, so I1 must be greater, and our polarity also, this is positive, this is negative, so this is a negative sign. Don't get confused over here. If you say, sir, this is the 20 volt, this is the 10 volt, so I3 must be greater than I1. Yes, it may be, but we till now we don't know. We are assuming now in this direction it is flowing, whatever may be the other voltage, but in this loop only one direction current should flow, that is I1. And if I1 is flowing in this direction, so we have to assign positive over here and we have to assign negative over here. That's why current is flowing from positive to negative. If you say, no sir, current I3 is flowing here, so we have to change this direction, but it is not as per the rules. Only one direction you have to mention. Maybe the ultimate current at the answer, it will come at the negative sign. But then we think, no, our direction was wrong. It was the opposite direction. It is the rules. Okay. So this is your equation 1. Okay. This is your equation 1. No, don't give it equation 1, because we have to solve it again, because something is coming. So this is the I1, this is minus 3 I1, this is plus 3 I2 into this is minus 6 I1, this is plus 6 I3. So you can see here, you can solve something. So this is 1, this is minus 3, this is minus 6. So it is coming minus 8 I1. That is, sorry, here the minus is there. Here is minus is there, so not 8. Because first time we are giving this minus over here. This is equal to 0. as per the law. Here is some dotted line is coming here, that's why I couldn't understand. I think this is the equal sign, this is not equal sign. Okay, equal sign is here, equal sign is here. So this is the case, this is your case. So this is minus I1, this is minus 3I1, this is minus 6I1. It will be your minus 10I1. 1, 3, 4, 4 and 6, 10. So this is minus 10I1. And then this is plus 3I2 and plus 6I3 equal to 0. So this is also equal to 0 as per this Kvl law. So this voltage is coming. So we can take this as in this direction. So 10I1 minus 3I2 minus 6I3, this, and it will be the equation 1. Okay, then same way we have to apply for mesh 2 and the mesh 3. Guys, could you understand this? If you have facing any problem, any confusion, you may ask me. So that is mesh 2. In mesh 2 you can see, in this mesh 2 you can see here is only a voltage source. Okay, but our direction is positive to negative. If I traverse in this direction, so this is positive to negative, so it will be considered as a negative. If then we coming here, then we coming here, and then we coming here, so we have to write down this minus 5 plus, you can see minus 3 of I2 minus I1 or you can see if you solve it. Okay, because minus 3I2 here, minus 2I2, and here it is the minus 5I2, so it will get 10I2, and this is minus 3I1, so this is 3I1 minus 3I1, and this is 5 over here. Okay, and this minus will come here, so this is positive and this is negative, so this is equation 2. And now for the mesh 3, you can see this is the mesh 3. Here two voltage is there, one is negative to positive and one is negative to positive, so both are should be in the positive sign. Okay, so for the mesh 3 it will be 20 volt plus plus 5 volt plus, that is minus of 6, sorry 6 is not here, minus 6 of I3 minus I1, and here another current is flowing through the 4 ohm resistor, that is minus 4I3 equal to 0. And now we can solve, this is easily 25 volt, that is minus 6I3 plus 6I, that is 1, and that is minus 4I3 equal to 0. So you can get 25 equal to this minus and this plus, this is 10. So 10I3, 10I3, and this is minus 6I1. So up to this we get these three equation. But now we have to apply the Cramer's rule. Okay, what is the Cramer's rule? Then we will solve it easily. Just look this equation. Here is it is in the resultant, that is your voltage, but here is in the current. So we can segregate is I1 I3 I1 I2 I3 current and its resistance something 10 something 6 or something, and ultimately this is voltage. So we can arrange it in a matrix form, then we can easily solve it. Okay, so then we are going for the Cramer's rule. Okay, this is step 4, step 4 or 5, or maybe is 4. Now Cramer's rule. ERS. Okay, ERS. Cramer's. So what are the equation? Just I write down the equation. This is the plus 10 I1 and minus 3 I2. Just write down in the format of this I1, I2, I3. Okay, equal to 10. It was the equation 1. And then minus 3 I1 plus 10 I2, and this is 0. It is the minus 5. This is the equation. And this is minus 6 I1 plus 10 I3 plus 0. Sorry, I3 should be here. Plus 0 plus 10 I3 equal to 25. Okay, this is your 3. Just remember this. Look, I1 is one side, I2 is middle, and I3 is here, and all voltages are here. So we have to apply it in a matrix form. Okay, so if I represent it in a matrix, so coefficient are written in this format. So coefficient are 10, that is minus 3, that is minus 6. And if we write down, this is minus 3, this is plus 10, this is plus 10, and this is 0. And this is minus 6, this is 0, and this is plus 10. Okay, we arrange this coefficient in this direction, and we just multiply it I1, I2, I3. So matrix multiplication is this is the row into column. So we have to write I1, I2, and I3, and this is equal to resultant will be coming in the 10 minus 5, that is 25. So we can arrange this in this matrix format. Now Cramer's rule is saying that we have to find out a delta. Okay, and then we have to also find out the I. We have to replace the value of the I in this direction, and then we have to find out this delta 1, delta 2, and delta 3. And if we divide it in delta 1 by delta, then we can find out the ultimate result. So what will be the delta? What will be the delta? Delta is just like this. Guys, just write down it and I will show the direction. Then after some times, whenever you forget it, you can remember again. That's why I'm right. Don't go for the directly application. Okay, this is minus, then again it is plus. Okay, just write down this matrix. Then we have to take, look, one by one we have to take. Say, if I take this 10, 10 is coming in this column, so left this column, and we have to take this one. So it is coming plus 10 is given into this cross multiplication and divided by this. So 10 into 10 and minus this. So this is 0. Okay, this is the solution. Then again it is coming the read minus, it is minus. Then we are taking this element because we have to take one by one. So whenever we take this element, so left all this part of this column. So left all this part of this column, just left. So we have to take only this one and this one. So cross multiplication over there, just cross multiplication over there. So this is 10, it is minus 3, sorry, this is minus 3, not 10, minus 3 into 10. So again minus 3 multiplied by 10 minus minus 6 into 0, minus 6 into 0. Okay, this is over and we coming. Just 10 minus 3 minus 6. Now we are taking minus 6. Minus 6 is the multiplier. So we we have to release this portion, this column, just cross it, just cross it, just cross it, and just cross it. Okay, and then you can find minus 6 is a multiplier. This is minus 6 is a multiplier. Then we are getting only this section. So this is 3 into minus 0 minus minus 6 into 10. So that is minus 3 into 0 minus of minus 6 into 10. Okay. So this is coming delta. Now we have to solve it. That is 10 into 10 into 10 into 10 means this is 100, 1000. 1, 2, 3, 3 zeros after 3 zeros, 1, 2, 3. Okay. And it is coming, look, minus 3 into minus 3. So this is plus 3 into 10 and it will given 0. So it is 0. Here it is coming plus. Here is minus 6. This is given 0. So minus 6 into 10 equal to 60. Minus 6 into 10 minus 60. Minus 60 into minus 1, it will be the plus 60. Plus 60 into 6 equal to what happens? 3 plus 60 into minus 60, it is 360. Minus 360. Okay. And ultimately it is coming 1000 minus 90 plus it is coming minus this. It will be ultimately it will be coming 550. Okay, so delta is that. It is delta. Now we have to find out delta 1. What is the delta 1? Delta 1 is just put the V, just put the total V. Say this is V1, this is V2, this is V3, and left others. So -3, -6, +10, then 0, 0, 10. We have to calculate it just like this. So if we want to calculate, put this value V1 equal to, what is V1? It was 10. What is V2? That is -5. What is V3? That is sorry, +25. And just put -3, -6, -10, 0, 0, 10. All are plus. So first we have to take this, then this, then this, then this, then this. So equation it is coming. If I we have to go for this equation is coming 10 multiplied by this area. So 10, 10 n into this 10 into 10 minus 0, 1 plus, then negative, then again plus. So then 3. So this is -3 into, look, whenever 3 is there, so only 25 into 0, 25 into 0, and 5 into 10, minus of -5 into 10. Okay. Then this is 6 minus, again plus. So -6 is there. So this area, okay. So -5 into 10. So -5 into 10, and that is minus, that is -5 into 10, and 25 into 0. Look this equation. Yes. Oh, sorry. You are taking 6. So you have to discard this area. You have to take only this area. So this is -5 into 0, -5 into 0, and 25 into minus of 25 into 10. So ultimately it is coming 1000 minus 150 plus 0 plus 1500. So it is coming 2350. Just remember, this is delta 1. This is delta 1. And now we go for, so I1, if I want to find out this I1 is just like delta 1 by delta. So delta 1 it is coming 2350, and delta is coming, that is 550. It is 11. It is 47 by 11. So it is coming, I mean 4.27 ampere. Okay, this is I1. Just like I2 will be delta 2 by delta. I3 is delta 3 by delta. So delta is given, but we have derived. But delta 2 we have to derive. What happens? So we have to put the value in middle of voltage. Say that is 3, that is 10, that is -6. Here is V1, here is V2, here is V3. Again -6, 0, that is 10. That is for delta 2. Okay. So we can solve it. Just put it the value. V1 is, what is the V1? V1 is 10, -5, and 25. So just do it. 10 multiplied by this area. So this is 10 multiplied by this minus 5 into 10. So minus 5 into 10 minus of this area 20 into 25 into 0. So 0. Then minus it is coming. So now it is this 10 is coming. So we have to put 10 is here and multiplied by this 3 and 10. In 3 and 10 and it was minus 3. Yes, it was minus 3. So minus 3 minus of this minus 6 into 0. So this is 0. Then again plus. Then it is coming here 6. Whenever 6 is considered, then multiplied in this area. So minus 3 into 25. Minus 3 into 25. Minus of minus 6 into minus 5. So this is coming in 30. But it is here is it is coming. So we can write down this. It is ultimately coming. Here is 500. Here is plus minus 3 equal to plus 30 300. Here is coming minus 75 uh, minus 75 into minus 75. Sorry, here is 6 is there. It is also minus. So what happens? Look, this is it will be coming ultimately. This is 6 into 75. This is minus 6 of 75 minus of 30. So it will be coming minus 500 plus 300. And then it will be coming, I mean, plus 450, and it is coming plus 180. Ultimately, if you add this and then minus it will coming 430. So delta 2 means I2 is delta 2 by delta 2, it is coming 430 divided by delta is 550. So it will coming at least it will coming actually 0.78 ampere. Just like this, you have to go for the I3. I3 means delta 3 by the delta. It is we have to find out it. If you find out it, then you can find uh, just like this, plus 10 minus 3 minus 6 minus 3 need 10 and 0. Here we have to v1 v2 and v3. v1 v2 v3, it is actually v1 is what is v1? 10. This is minus 5 and this is 25. So if you go for the equation, then we can find this 10. First this is 10, in this is 10 into 25 minus of minus 5 into 10. Sorry, this is not 10, this is 0. And then it will minus of minus 3 into minus 3 of into 25 minus of minus 5 into minus 6. Next, then again plus 10 n into minus 3 into 0 minus of 10 n minus of minus 6. It is ultimately coming 2500 minus 315 plus 600. It was ready-madely done. That's why I'm doing this, but you have to do this. Okay, then ultimately it will coming 2785, and we know I3 is the delta 3 by delta. So delta 3 is the 2785 and delta is 550. So it will coming actually 5.06 ampere. So you can find all these things. So in this way, we can apply this Cramer rule. You can see how Cramer rules is working. You have to put, if we want to voltage V2, so I2, so put see value of V2, then solve it. And first you have to solve delta. So I1 is the delta 1 by delta, I2 is the delta 2 by delta, I3 is the delta 3 by delta. That's this is the Cramer's rules. In this way, we can go for the mesh analysis. Okay, guys. Guys, if you have any question, you may ask me. Okay, time is very less. So